We all set? Suspense.
We can't check because we won't have a video recording of the first one. So we can't check if they're identical.
We've got a video recording, just no sound.
Oh, all right. You should try and make it frame the same.
So last class, before spring break, we derived the formula for change of variables into polar coordinates. And so you'll remember it looked something like this. We had a double integral over region D, and we were integrating a function of x and y. And we found that that was equal to a double integral over a region D star of f r cosine theta, r sine theta, r d theta. So today I just want to do an example to use this formula for change of variables into polar coordinates. So we're going to take a look at a region first, and then we're going to look at an integral over this region. So in Cartesian coordinates, this region is going to be given by the area in between two concentric quarter circles. So I'll start here with the point 1, 0, 2, 0, and then circles, and so this will be the point 0, 1, 0, 2. Okay. So here we have we have the area between the two quarter circles, x squared plus y squared equals 1 squared or 1, and x squared plus y squared equals 2 squared. Okay, and we're going to want to integrate the following function over this region. We're going to want to integrate, we'll say log of x squared plus y squared. Okay, and so this is going to be our region D. And we want to now find our region D star. And we want to find what the integrand will be over here. So let's find what the region should be first. Now, you'll note that we could definitely integrate this over Cartesian coordinates, but it would be slightly complicated. It will be very simplified if we note that, when we convert to polar coordinates here, right, r squared is equal to x squared plus y squared. So when we do our integral, r d theta, right, so when we try to convert our integrand in terms of r, we're just going to wind up with log of r squared, right? That's the function we're going to be integrating. Okay, so now we need to figure out what this region D star should be. Okay, so let's draw our polar coordinate system with theta here and r here. Now the r's, let's just do this geometrically first, and we can look at it algebraically. We can see that the radius, right, is just going from 1 to 2. So it actually just sort of matches x, right? So we can just have r going from 1 to 2, right? And now theta, where's theta going? Well, theta is going to be going from 0 to pi over 2, right? So 0 to pi over 2. Okay, so we've got this, and there's a bit of colored chalk, I guess, so we can see that we're sort of this guy here, and this guy. got our new region, and this is D star. So we have our limits then are going to be, well, we've written r first here, so r is going from 1 to 2. And theta is going from 0 to 2 pi, or to pi over 2, I'm sorry. Okay, and so now we're ready to integrate. And to me, this looks a lot less intimidating than this integral over here. So let's get started. We'll just actually, I don't know if I'll have time to compute this, but I'll give this integral to you again on your homework with a different region. Okay, so you will see it again, but we can get started as far as we can go. So this is we have the exponent rule for logs. We can bring that 2 out front, and we'll just rewrite the integral quickly as 2 integral from 1 to 2. So 2, and then we have our r from the change of variables formula, log of r. Okay, so this integral, which technique do you guys want to use for this integral?
Integration by parts.
Integration by parts would be an excellent way to do this. You may also remember that there's a formula for, x log x or whatever, but let's use integration by parts. Okay, so let's think about what we want our u's and v's to be. I would really like to differentiate log, because that'd be like super easy to do, right? I would like much less to, have to integrate it. So let's pick u to be equal to log of r. So du will be equal to 1 over r dr. Okay, and so dv is going to be equal to 2r dr. So remember, with these double integrals, okay.
Should we have a d star on the left?
Yeah, it should be d star on the other one instead of.
No.
Look at your integrals.
The picture.
Oh, I'm sorry. In this thing, this should be d, not d star. That's the thing. Cool. Thank you for listening. Whoa, that's really spread out.
I don't think it's bad though. It's perfectly beautiful.
Any comments or
RDR d theta over there is kind of floating off in space.
Yeah.
Oh,
I like
yeah.
what you're trying to do, sort of set that up before you put in the integrands.
Yeah, that was quite I like how I randomly changed the yellow chalk too.
Yeah.
Keeps things interesting.
okay? Well, I thought it was a good choice of example.
It was a book choice, a modified book choice. So thank you.
Good.
That was a pretty good first example for public course.
Modified instead of exactly from is good.
Okay.
Yeah, so. Okay, so next person, I guess.